Here's an example where we want to solve for x, and x is in the exponent. Notice before we go any further, the base of this exponential equation is e, and as a reminder, log base e of x is just the definition of what we call the natural log. So if you just see ln x, there's an implied base there of e. Since I have a base of e, I'm going to take the natural log of both sides of this equation. You can apply the natural log or any log of any base to both sides of an equation, and it'll still be equal. And now I'm going to apply the power property and pull that 2x plus 1 out in front of the natural log of e. So I have 2x plus 1 times the natural log of e is equal to the natural log of 11. Since the natural log has a base of e, then the natural log of e is 1. And so this all simplifies down to 2x plus 1 equals the natural log of 11. Now just a note, I could have actually gotten here without having to perform all of these steps. I could have taken this exponential equation and converted it straight into logarithmic form. Since this is a log with base e of 11 equals 2x plus 1, you could have jumped right down here as well. Either way works. Now I'm going to solve for x, so I'll subtract 1 from both sides, and I'll divide by 2. So again, this would be my exact answer because I cannot simplify anything any further, and I've not had to make any sort of roundings or approximations. But let's get an idea of what this number actually is. So we'll type it into the calculator, and we'll get an approximation of 0.6989. Why don't you try an example kind of like that? Want to get the e to the x or e to the whatever by itself, and then we'll go from there. So pause the video, give this one a shot. And here's my solution for this one. You can see my workings out here, and I have an approximate solution of 0.7575. Let's do one more example like this. Oh, there's my answer. Let's see if I can't work my way there. I have a little bit more complex of an exponential equation here. I've got 3 times 3 to the x minus 30 equals 300. And since I have an x in the exponent, I know I'm going to need to use logs at some point, but as it stands, I can't really take the log of both sides right now. I'd like it to be something that I could work with. So my goal is to get this into the form some base to some exponent equals whatever. If I have something that looks like this, now I can convert to exponential form. So it's kind of like what I'm thinking to do is isolate this 3 to the x. So I'll do that by first adding 30 to both sides. So that I get 3 times 3 to the x equals 330. Then let's divide 3 on both sides. And so that becomes 3 to the x equals 330 over 3. But we know that that's equal to 110. Now I can convert this to logs. I could take the log base 3 of both sides, or I could just skip a whole bunch of simplifying steps and jump straight to logarithmic form. So x is going to equal log base 3 of 110. And I think I typed this in the calculator. We'll see if we get this 4.2786. And hey, what do you know? There it is. I did round it out to 4 decimal places, so that's why this guy rounded up. And here's my approximate solution, and here's my exact solution. Why don't you try this example, kind of similar. Think about isolating the base, and then use logs to solve. And here's my solution for this one.